Hi everyone. In this video, I'm going to show you how to solve this exercise 3. So you have a plane wave in non-magnetic medium. So what is non-magnetic mediums? It means that the relative permeability of this medium is equals to 1. Okay, so this refer to non-magnetic medium. Okay, so these mediums, okay, this plane wave has electric field formulas equals to this. Okay, so you have to find the direction of the wave propagating, okay, the lambda, the frequency, the relative permittivity, and also the equations of the magnetic field. All right, so now let's look at the information that is contained in the formulas of these electric field. Okay, so obviously this one is representing the amplitude. Okay, so unlike the previous two exercises, so for this question it doesn't have these exponent term. Okay, this shows that this medium, okay, is a lossless mediums. Okay, it's a lossless medium because the wave amplitude, okay, will remain the same throughout the whole transmissions and propagations. Okay, so this is a lossless mediums. Okay, lossless mediums. Okay, so for this lossless medium, it has angular frequency of 10 power 8. Okay, and here you see positive Z. Okay, so positive Z is showing that the wave propagation is in the negative Z directions. Okay, and the beta is equals to 2. Okay, and the electric field, okay, direction is equals to Y directions. You can refer here. Alright, so the first question is the direction of the wave propagations. Okay, it's wave propagation, so it means that it is referring to this unit vector k. Okay, so can write down that the k, okay, is equals to negative z directions. Okay, you can just write down like this. Okay, next will be the alpha. No, next will be the lambda. Okay, b, lambda. Okay, lambda. So how to find the lambda? Okay, so you can find the lambda by using this formula. Lambda equals to 2 pi over beta. Okay, if you're not familiar to these equations, let us move back to the lossless dielectric. Okay, so for lossless dielectric, you can see that the attenuation constant, the alpha is 0, and this is your beta. Okay, and this is your wavelength. Okay, so you can calculate the wavelength by using these formulas. Okay, so let us put the value is equals to 2 pi over beta, which is 2, so it is pi. Okay, pi. Okay, which means that it is 3.142, okay, meter. Meter is the unit. Okay, so this is the wavelength. Okay, next we are going to calculate, next we are going to calculate okay, we are going to calculate the frequency. Okay, the frequency. So we know that the frequency we can calculate from this angular frequency, because the angular frequency is equals to 2 pi f. So the f is equals to omega over 2 pi. So your omega is 10 power 8 and 2 pi. Right. Okay. So you can calculate it is equals to 15.92 megahertz. Okay, so this is the frequency. Right, next is this. Okay, the relative permittivity. Okay, relative permittivity. How do we calculate this? Okay, so let us flip back, okay, to the formulas for these lossless, okay, dielectric. Okay, so since this is equal to 0, we can relate, okay, the beta, okay, the beta with the relative permittivity using the formulas, using these formulas, the formulas of beta. Okay, so we are going to use this. Beta equals to omega, okay, and mu and epsilon. Okay, so since this is a non-magnetic material, so we can replace the mu, okay, with 1. Okay, 1 mu naught. Okay, this is the permeability of free space. And here is the relative permittivity that we want to find, and it must be multiplied with the permittivity of free space. And for the beta, it is equals to 2, given by the questions. Okay, so 2 over 10 power 8, okay, is equals to mu naught, epsilon naught, and epsilon r, and square root. Okay, so you can square both sides, okay, to remove the square root. Okay, so it will become 2. Okay, so let me do this. 2 over 10 power 8. Okay, so this will become 4 times 10 power negative 16. So equals to mu naught, epsilon naught, and epsilon r. Okay, so next you can calculate for the epsilon r, which is equals to 4 times 10 power negative 16 divide with mu naught, epsilon naught. Okay, so divide answer divide by this. Okay, you can get these two values from the calculator. Okay, so it is 35.95. Okay, so this is the relative permittivity. Right, next is to form the equations of the magnetic field. Right, the equation of the magnetic field. Okay, so for magnetic field, the formulas, okay, the general formula I would say. Okay, the general formula will be A. A represent the amplitude of the magnetic field. Right, since the electric field is sinusoidal waveform, sine waveform, so here you plug in the sine as well. Okay, and then it will be plus 2 z. Okay, so this is the same. Okay, and for the h direction, you need to figure out. So you need to figure out A and also the h. Right, A and also the h. So how to figure out the h? So by using this relationship between the directions of the electric field, the direction of the magnetic field, and also the directions of the wave propagations. Okay, so you can fill out the direction of the electric field according to the question is y, and h is the things that you want to figure out, and the k is negative z. So over here, okay, your hash will be equals to x. Okay, you can play around, okay, whether it's x or negative x. Okay, right, so this is the directions of the magnetic field, and for the directions of the electric field, right, so we need to use this relationship. Okay, but we need to know first what is the eta, right, the intrinsic impedance. Okay, so let's flip back to the lossless. Okay, and let's see how to find the intrinsic impedance of lossless mediums. So for lossless mediums, okay, there is no angle. Okay, there is no angles, so we can use these formulas in order to figure out, okay, the intrinsic impedance. Okay, so it is equals to mu over epsilon, right, and square root. Okay, so mu naught, okay, over 35.95. Okay, so this is the value that we calculated just now. Okay, so you can put in the value to your calculator and to get the answer. Okay, so this is the intrinsic impedance. Okay, so now the h will be equals to E over the eta. Okay, the intrinsic impedance. Okay, so for the E, according to the questions, the amplitude is 50. So divide 62.83. Okay, 62.83 is 0.796. Right. Okay, so I will write down here. So the amplitude of my magnetic field is 0.796. Okay, I'm using sine 10 power 8 t and plus 2 z. Okay, and the directions, I refer to the directions over here, which is x. Okay, and the unit is ampere per meter. So this is the formulas of the magnetic field. Right,